instead of imagining two chords meeting up at their endpoint somewhere, let's imagine that we have two chords that just cross somewhere inside the circle. For example, take a look at the chord AD and the chord BC. Well, they don't actually sort of emanate from the same starting point on the circle, but they do cross inside the circle at E. And so it's interesting to wonder if there's some kind of relationship between, this angle, angle 1, which by the way we know by vertical angles equals the measure of this angle here. If there's some connection between, these angles and the arcs. And the beautiful thing is the answer is yes. And it's kind of what we might guess, which is that the measure of this angle actually is equal to 1/2 the measure of one arc plus the measure of the other arc. In other words, in some sense, the measure of this angle is the average of the measures of the arcs. We add the arcs and divide by 2. So again, we're seeing some incredible properties that circles possess because of the beautiful symmetry. Let's take a look at an example. So here I have a couple of lines cutting through the circle. They intersect at E, and our challenge is to find the angle BEC. That's what we want to do. So I want to find this angle. Well, if I know that this arc has a measure of 80 degrees and this arc has a measure of 28 degrees, well, then I know that this angle actually is going to be equal to the average of these measures. So all I have to do is add them up and divide by 2. So if I add them up, you can do mental math and see that I'd get 108. And if I divide by 2, half of 108 would actually be 54. And so I can see immediately that this angle right here is 54 degrees. So using this formula, we actually can develop even greater insights into different angles inside of circles.